Hello, and welcome back. This video is about using a custom game instance subsystem for saving and loading both custom and generalized data, and we'll see it in action for a few different use cases. And a special thanks to all my supporters. Thank you for helping me help others. We're starting with a fresh Unreal Engine 5.7 third-person C++ project named SGS. So the first thing we're going to do is create some C++ classes. First is going to be based on SaveGame. SaveGame is a built-in class that is used for saving games. And Unreal has some utility functions for saving and loading those classes, so we'll need to subclass it and then follow a few simple rules. All right, next up, we're going to subclass the Game Instance Subsystem. And we're going to call this one UMySaveGameSubsystem. So my SGS. And lastly, we're going to create an actor. Oops, I'm going to do that right here. And we'll just call this one AMyPickup. And with this all done, we'll just switch back to the editor. Which has then loaded each of those files. Pop that closed, pop this open. I did forget that I do have to reload. I like to see my files, even though I'm not going to use them right now, and we're not going to use the variant stuff currently. So first of all, I'm going to overwrite everything in our UMySaveGame here. So the first thing I like to do, because the .generated file needs to be the last one included, I just throw an extra space in here just to kind of remind myself. So for right now, our save game is literally just going to have one int. We're calling a pickup count, and you do always have to remember uProperty. If this is missing, you will wonder why your values, even though you're setting them and getting them, they're not being saved. So make sure that's in there. Nothing that is missing that will be serialized. We're not currently doing anything with UMySaveGame CPP. So in our UMySaveGameSubsystem, replace this with lots of stuff. So first of all, I'm going to tell the compiler that we have two classes up here we're going to be using. So our UMySaveGameSubsystem is just subclass from UGameInstanceSubsystem. A Game Instance Subsystem or a subsystem is just a separate class that is loaded depending on the component in Unreal that controls it. So obviously the game instance is the part that controls this subsystem. And what that means is that when the game instance is first created, initialize is called on it, and then it calls initialize on all of the subsystems. So the lifetime of a game instance subsystem is very slightly less than the lifetime of the game instance, which you probably know is the entire lifetime of while the game is running. So first of all, we're just keeping a pointer to our UMySaveGame. And we want this to be a T object pointer. Previously, we used to just use straight pointers, but we want this now. We want this as a U property because the garbage collection will get rid of it otherwise. And we have functions for initialize. We are supplying a static function just to make it easy for other components, other actors, etc., to get this class. And then we have three main functions for creating the save game, loading and saving the save game. We have two callbacks that are used when you're asynchronously loading or saving the save game. And then we just have two getter and setter functions for the pickup count that we set in our save game. So with that done, we'll run through the code in our CPP file. So first off, again, when initialize is called, this is right at the beginning of game instance. The first thing we're doing, we're just calling load MySaveGame. So we'll start there. So in load MySaveGame, I'm just getting a slot name. We're setting this to a value. The slot name is what the save game system uses to differentiate between different save games. So for example, we're just using MySave. If you wanted to, you could have a number on the end or any other signifier, maybe a time and a date, to throw that in the file name so that it can be different things. Secondly, we have a big section for asynchronous and not. The difference is that for asynchronous, we're just going to be calling async load game from slot instead of directly load game from slot. So to set it up asynchronously, we need to create an async load game from slot delegate. And in that, we're binding the function that's going to be called when the game has been loaded. We send along the slot name and of course that loaded delegate, and then this function will get called when that's done. If we're not doing asynchronously, we're just calling load game from slot. It's returning a USaveGame, which we're casting to our type, assuming the cast is correct, which it really should be. Then we're all good. Down here, if you had some save game information in other classes, then you might want to access it here. So similarly, if we go to the asynchronous version, we hit F12 on this, it goes in here. It's sending along the save game in loaded save game. So again, we're casting to our version. And of course, if it's not successful here or above, we're actually calling create my save game instead. And similarly, if we had variables that were in other classes, we want to handle them here. So in create save game, what's happening here is we're calling a create save game object. This is one of the utility functions I mentioned. There's, of course, create, load, save. There's also delete, and I forget what the other one is. If we go into here, hit F12 a few times, you can see that it's not in the order I would like. Hit Control F3 to go through this file, and that's not helping. There we go. So I was clicking on the wrong, or hitting find reference on the wrong thing. We have create, we have our save, delete, and whether it exists or not. So those are the 5 main utility functions you have available for save games, and they're all going through slots. Just hit back a few times. So back here, when you have created your new save game, it's good to have your default values being set. Pickup count would have already been set to 0, but this is fine. Once we are creating our save game, then we want to immediately save it so that it's around and we don't have to recreate it every time when it's not being saved. The last thing I'll mention here regarding loading and saving is that up here, when in our effectively, it's an auto constructor, but it's comparable to begin play. This does run before all the begin plays, but nonetheless, when we're loading our MySaveGame, we're setting along false. So that means we want to load the save game synchronously, not asynchronously. That's important at this point in time because that means that this function will finish. It will return, the MySaveGame will be ready, and then after initialize has been called from Game Instance and all the Game Instance subsystems, then begin play is able to be called. If you have this set to true, there's a chance the function here on my game save loaded will actually run after other stuff has run through begin play or started running through begin play. So we don't want that. Last thing of note in here, we have a similar version on saving. So I'll go through saving, which is save my save game. If we don't already have a save my save game, then that's an error. So we just return. Similarly, in the load section, if we have variables set in other classes that we want to save into our MySaveGame, this is where you'd set them. And then similarly, we're setting the slot name to MySave. And then if it's asynchronous, we're calling async save game to slot. Otherwise, we're just calling it the direct save game to slot. In both cases, it's taking the save game, it's taking the slot name. In this case, similarly, it's using a async save game to slot delegate, and the save delegate has a function bound to it as well, and then that will get called when you asynchronously save. This is mostly handy when you are doing an autosave system because you don't want anything in the game interrupted by the save, so you do it asynchronously. So similarly, when this gets finished, it's actually right here. When this is done, it's not really doing anything. It's just checking whether it was successful, giving us a log if it's not, and then we can investigate that. However, the reason I have this comment down here is that if you do have an autosave system, you probably want some kind of notification to the player before the game has been saved, and then at this point, it's when it's been saved, and you can remove that notification. Very commonly, there's an icon, blinking in the bottom right corner. You would start that before calling this. I would give it a few seconds before this is called, so you'd want to set up this flow a little differently, and then you turn that notification or image flashing off at this point. Lastly, we have our getter and setter for pickup count. We're just currently using public variables in our save game. If you wanted to, you could have your getter and setters in this class instead, but for now, we're just saying that SaveGameSubsystem owns this class, so it has access to it in that sense. So simply put, getting pickup count will check to make sure there's a save game. Same within our set pickup count, and it just returns the value or sets the value appropriately. Lastly, we have our AMyPickup class to show some of this in action. So our AMyPickup actor, we're just basically creating a mesh component and a sphere component. And then we have our overlap for when the sphere component is overlapped. In the CPP file, we're just setting up our static mesh component. We're making sure it's the root component, and I'm just setting the scale to 0.2 because in the editor, we're just going to set it to like a default cube. So we're making the cube smaller. Since this one, our sphere comp, which is attached to the root component, which is this mesh component, since that's going to shrink by 0.2, we're just going to make that one also larger. So this one is basically shrunk by 4, and this is, expanded by 5. So then in our begin play, we use our sphere comp, and we call our on component begin overlap. We're just adding the on overlap begin so that when we overlap, this is what gets fired. In this function, then we're just checking to see if the other actor, the actor that collided, or rather the actor that overlapped with this sphere component, make sure it's not a character, or rather, if it's not a character, we'll just immediately return. In the case where it is a character, then we want to get our UMySaveGameSubsystem, and this is the static get function I was talking about. We can just have our pointer call that get function. Similarly, you could put this into a class like the gameplay statics. You can make your own, which I've done in a previous video. But in this case, we just made it part of this class to make it easier. It is effectively a singleton, so this is following that pattern. So as long as it's valid, and it always should be. So we could actually, instead of checking if all the time, we could pretty safely just do a assert macro, which is check F, throw in the UMySaveGameSubsystem, throw in some text, yes, or my SGS is bad. And in this case, anytime it's null, then this would fire off and and effectively it would throw this message in the output, and then you'd know that's why that happened. We're just going to leave that out for now, but it is a good tool to basically show the developer that you messed something up. So in that case, we first want to get our pickup count from the SaveGame subsystem, and then we're immediately calling the set pickup count and just adding one. This could be a variable in this class, but for the simplicity of this video, it just made it like that. And then, of course, we're destroying our pickup right after that. So let's hit F7, make sure that I didn't miss anything in my copy pasta. All right, that looks all good, so I'll see you in the editor. Well, it did look all good, but I forgot to put the static get function in. So we're just going to add that in our CPP. Just going to throw this at the top because it's kind of the initial thing that happens. So basically what this function is doing, it's a static function. So you're just calling it through that, like we saw in the pickup count, or in AMyPickup rather. So we're calling UGamePlayStatics. It has a function which is called getGameInstance. That'll give you, obviously, the game instance. You use the game instance to get the subsystem, and you're sending along the class of the subsystem that you're trying to get. And if this failed, which it really never should, because the game instance is always around, it will return null otherwise. So let's check again, and then I'll see you in the editor. All right, so back in the editor, I'm just going to create a new folder to keep my stuff contained. I'm just going to call this SGS. So the first thing I'm going to do is create a widget. So I just create a user interface widget blueprint. It's type user widget. We're going to call this WBP HUD. So since this didn't load up right in the main window, I'll just go into my editor settings, and in the asset editor open location, we'll just set this to main window and close this. Once I reopen that now, it's just put in the main window. Just prefer that. I also prefer in our compile here, I just click on this, go to save on compile, and I want always. So on our HUD here, we want a panel, canvas panel. I'm going to create a horizontal box. And in here, I'm just going to put in a button, a text block, and another button. So this will be load button. Our text block will be our pickup text, our pickup count text. And lastly, this button is our save button. I'm just going to make this about 300 by 50. And I want to make each of these entries fill. So they just take up as much space as I can. And our text, we want this justified in the center. We'll just set this initial text to 0. And I'll center it vertically as well. So super basic, but it's not really the point of the video. For our pickup text here, we want this to be set for the text. We want to bind this. Binding is not a great way of doing this, but again, it's not the point of the video, so we're just going to do it this way. Oops. So you've seen in C++ how you can get access to the SaveGame subsystem by calling the gameplay statics to get the game instance, using the game instance to get the subsystem, and supplying that. In Blueprints, it's a little easier, like many things are. You can just right-click on the background. You want to type get my SaveGame subsystem, and there we have it. You may have seen this with other things like the enhanced input system. So for here, we just want to call our get pickup count. And we're literally just setting that value based on that. Make this look a little less messy. And there we have it. In our graph, in the event graph, we want to also get our buttons. So for our load button, we want on click. And for our save button, we want on click. So similarly, we're going to get our get my save game subsystem. And in here, we're just calling load my save game. Since we're doing this on demand, we do not want to click is async because we want it to just happen. And similarly, we're going to call save my game or my save game. And to make this lovely UI show up, we want to go into our third person character in begin play, which is not set up. We're just going to then create widget. We select our WBP HUD and simply just add to viewport. Should not need either of these open going forward. So in our SGS folder, we want to also create a blueprint class. This will be based on our pickup. And we just call this BP pickup. or MyPickup, either would work. So like I said earlier, in here, we're just going to set our mesh component to a cube. And you can see because of the sizing I already set up that the sphere area is surrounding it. And by default, the mesh or the static mesh component is collision based, and the sphere component is overlap based. So that's all set up properly as is. So if we then just throw down a few of these pickups, I'm being a little too particular here, but I wanted 4, and I like spacing. All right, so with that done, we go in here, we hit play. We can see that our counter is showing 0, and as long as I didn't mess anything up, as soon as we pick one of these up, it goes to 1, 2, 3, 4. So we're good to go. Now if I hit quit and then restart, you will see that the value is still 0. The reason why that is because there's no mechanic to automatically save a game. So we just pick up these again. We have our 2. We're going to hit Shift F1 to give us the mouse cursor, and we'll just click on save. If we then cancel and start, we're starting at 2. So we see that that's working. So before I forget to mention it later, your save game files, they are basically just the name you use for the slot, .save. And I'll put this in text on the screen as I talk about it. When you're doing a development build, it's going to be in your project folder under a Save Games folder, and then it will be a saved folder with the contents. That saved folder, when you're doing it a shipping build, will be, at least on Windows, in your %local app data % your project name /saved. Again, in the saved folder, we'll have your save files. So with that done, I'm going to go back to the C++. So in our save game data here, we just have a simple int pickup count. So this is fine. If you want to have very specifically named data and variables for easy access, for easier understanding, that's all good. However, if you're going to do something as generic as just a pickup count or a bunch of other variables which are the same type, so either integers, floats, bools, etc., another easy way to set this up is that we can just set another uProperty, and this would just be a map of fname, and both these are spelled wrong or capitalized wrong, to int, well, in 32 in this case, and we'll call this int values. So this will work similarly to the pickup count, except instead of directly doing a pickup count, we just have a map of pickup count, so the name that we'll send is pickup count, and to the value. So to set up our getter and setter is kind of similar. We'll do this in here. And here instead we have just a generic get int value, set int value, and we're sending along the fname, and in the case of the setter, we're sending along the value. In the case of the getter, we're sending the value, or returning the value. Similarly as before, we have our create my save game situation. We would want it to look like this. So if you want to set initial values for anything in that array, you're just basically accessing the array, adding a value, you're sending along the fname, and then the value. So similarly, we have our get int value and set int value functions, which we'll throw down at the bottom. So again, in both cases, we're just making sure that my save game exists, which it always should. And then we're getting the int value array, or we're getting the int value map. If it contains the name that we're sending in, then we'll return the value in that map. Otherwise, we return 0. Similarly for the set, all we're doing is getting that map, and we're just adding an entry to the map. If there's already an entry of the map that has the name, this will just overwrite it. If there's nothing there, it will actually add it. So similarly, in our MyPickup, we want to change this functionality here slightly. So instead of using this, and I'll leave this in here commented for anyone that wants to look at the code. So here we then we're just setting a fname to the pickup name, and we're calling it pickup count, which matches what we had. Instead, we're calling the get value and then the set value, sending in, the get value +1 like we did in the pickup name being sent to both values. So while the system is more generic and it's easy to just add any new value by using a unique fname, the problem is then you have text or a string literal that if you want to use in multiple places, you have to make sure you're using the same thing. In which case you could also, if you wanted to, this could just be an enum, and then you have to manage the list of enum values or, whatever else. But since we have this set up like this, we're going to we're going to go back to the editor, and I'll show you the change there as well. So then back in the editor, if we hit play, you'll see that we have the value, the old value. If we go and pick something up, you'll see that it didn't change. So the reason it didn't change, I mean, it did change, but it's not showing the change is because in our HUD, we have our pickup count binding, and this is still using get pickup count. So we now want this called get int value. And like I was saying here, we're using the name in a separate location, so potentially error prone, because for here we have to make a literal name, and then we have to actually type it in. So if you find that, you change something around and it's not working and you're using an fname or similar, it is prone to error, so it's a good thing to double check. There's one reason why enums are better, but then enums have their own, things to worry about. So with that set up, then again, we're back to 0 because it's that new int value. We'll go and pick up a few of these. And it's incrementing fine. We'll hit save just to make sure. Stop and start. Good to go. So then lastly, go back to the editor again. So in this case, we used our pickup count directly. You may prefer that, that's fine. Putting in a map is another method. Pros and cons in either way, that's all good. One other use case that's handy for save game stuff is that in some games, like Souls-likes, which I'm a fan of, the first time you fight like the Black Knight type character, you fight it once, you defeat it, it never comes back. So to do something like that, then we'll use it with our pickup object instead of an enemy, is that we then have an array. We need an fname for the key of that array effectively. And we're just calling this one-time objects. So with that setup, we want a new set of getter and setter functions. And in this case, I'm just calling it has one time and add one time. So has one time is just returning a bool, whether the one time has been loaded or it's in the save game. And then add one time, it's putting it into the save game. So the functions for these things also fairly simple. They both, of course, start with checking to make sure that my save game is valid. And then in the case of has one time, it's just checking that array and calling, is it contained or does it contain the one time name? And of course, for the add one time, we're just calling add and sending in the name. Very simple. To make this work, in our myPickup here, when we've picked up the object, we want to then have, oops, and I forgot, the first part I need to do is throw it in here. We have a new variable. We'll call this fname one time name. And we'll copy this. However, we want this to be editable. So we'll make this edit anywhere and blueprint read write. So then in here, we're checking to see if our one time name is valid or not. If we've never set it, it would be set to none, and then we don't want this code to run. So if it is not set to none, then we want our UMySaveGameSubsystem to call add one time name. So then that's on pickup. We're setting the one time name. However, how do we prevent it from being created? We kind of don't. We kind of cheat. Basically what we're doing that is when this actor, which is in our level, when this actor begin play is called, similarly, we're checking to see if the one time name is not none. In the case where it's not none, we're getting our UMySaveGameSubsystem, and then we're just calling has one time. So if the one time name that we've given this specific pickup is already in the save game, then we would just want to destroy this pickup and return. So this is not the best design because this is basically the object gets created, or it gets spawned, begin play is called in it, and then we're checking logic to then destroy it immediately. On the one hand, this is kind of a normal flow in Unreal, and Unreal does this as well in some of its own stuff. However, it's not a great design, but the way that you would get around it is that you would need to create a spawn manager or a pickup manager or something like that, and you wouldn't actually be spawning the pickups. You'd be checking to see if that pickup has a one name or a one-time name, and then just don't spawn it if it does, or if it does and if it's in the has one time. But of course, that's out of the scope of the video, but that would be one way to improve this. It's not really going to make a big difference unless you have like, a ton, hundreds, thousands maybe, of objects that are doing this check and deleting themselves or destroying themselves immediately. So with that done, we'll go back into the editor. So now back in the editor, we'll look at our spawns here, or our pickups here, and we have our one-time name. So we'll just call this one pickup 1 and call this one pickup 2. So then when we hit play, we're at 3 right now. We go and pick 2 of them up. We're at 5. Make sure that we actually manually save the game because we don't have an autosave system or anything like it. So that's saved. We stop, we restart, and we can see that the one that had a one-time name is gone now. And similarly, the one over there, same thing. We'll hit save, we'll stop and start, and now that one's gone as well. How useful that is for items depends on the design of your game. There's a lot of games where an item might be on the ground, it might be in a chest, and it's only ever gathered once per playthrough. But then, some other cases like in shooters where you might have armor or health or whatever else lying around, and every time the map is loaded, you want them just, showing up. So thanks for watching. If you liked the video and would like to see more, you know what to do. And if you would like to support this channel, watch these videos 2 weeks early, or just want to download the project files, you can do so through my Patreon linked below.